Hello, and welcome to our presentation, The Decision to Use Drones as Part of an Organizational Safety Program. I'm John Benhart Jr. I'm a faculty member in Geospatial Sciences at IUP. I'm also a GISC certified GIS professional and an FAA certified remote pilot, and I am the Director of Uncrewed Aircraft Systems Programs at IUP. I'll be joined on this presentation by Julia Wazen, who is an IUP Safety Sciences graduate, a certified safety professional, and safety program manager for Allied Universal. Many of you may already be aware of the definition of what a drone is in the United States, or small unmanned aircraft or small uncrewed aircraft. The definition, according to the Federal Aviation Administration, the FAA, is any aircraft that weighs less than 55 pounds and is controlled without possibility of direct physical intervention. So the main definition of a drone in the U.S. is this weight, less than 55 pounds. So if you're a safety professional and you're considering the use of drones in your safety program, one of the first things that you're going to want to consider are what are the pros or the value-added aspects of using drones as part of your safety program. And then, of course, what are going to be the responsibilities and the requirements and perhaps the costs of implementing such a safety program. And so I will be going into aspects of this moving forward in the presentation. So we'll start out with a discussion of the pros or the positives of drone use, and there are several. The first and probably the foremost is the ability to reduce worker exposure to hazardous environments. So obviously high places and places that are difficult to get to, we could use drones to navigate to those places and to shoot footage of those places and not have to put people in harm's way. And in many instances that would be a factor that many would be interested in. Secondly, enhanced visibility and perspective. I'm always amazed by the ability to gain a new perspective from the air. I always think I have an idea what it's going to look like, and drones just provide a perspective and provide visibility on infrastructure and equipment that in landscapes that are just difficult to come by anyplace else. Certainly drones in many instances will allow you to undertake inspections faster, but also with the ability to perform those inspections at different time frames that they're replicable. So you could have a flight plan and you could refly that exact flight plan to obtain data at exactly the same altitude, exactly the same resolution, covering exactly the same area. The ability to acquire data from the air and process it and analyze it also again. So you're not only able to replicate flight plans and flight areas, but you're able to process the data and quantify the differences over time. And that's a very powerful capability. Myself, a lot of times I will fly drones, acquire data, and process it in a GIS environment to undertake mapping and other geography-related analysis. You do have the ability to do real-time monitoring, so you could be broadcasting the footage that you're getting from the drone onto a larger screen and have the ability to look at that footage and to evaluate it in real time and to respond to it in real time. And then in some instances, the use of drones could be more cost effective than having to use multiple staff members to do things. For example, inspecting pipelines or other infrastructure, you'd have to have people walk long distances, perhaps over hours or days, as opposed to being able to fly a drone over those things. So here's an example of enhanced visibility and perspective. So we were doing some work actually for our local borough, as well as the County Department of Economic Development and Planning. And so we were out doing some shoots, and the county asked us, these buildings were owned by the county, and they asked us to shoot footage of the roofs of a few buildings that they were concerned had some issues. And so you can see here that you're able to fly at different altitudes, and then in addition, you can use the zoom capabilities of the camera to really get down and get very high resolution photography and videography of infrastructure, in this case, a building roof. And so you can actually get down. The resolution of these images is going to be less than an inch, and so you can zoom down and really see if there are issues with the roof. There had just been a thunderstorm a little bit earlier in the day, and be able to see exactly what's going on and zoom in and get very detailed images of the infrastructure, and then be able to review those, go back and review those over time, which also is very useful. Here we have a flight that we did around a building under construction on the IUP campus. In this case, it's a new science building, the Kopchick Science Building. And so you can see that you're able to fly at different altitudes from different angles and orientations. And it's very easy to see how the work site has been left. So you can see where equipment is left, materials are left, whether workplace protocols and safety protocols are being followed. In this instance, there weren't any workers here. This is after the workday was over. But this would make it quite easy and clear to be able to see how the workplace is being left, and you can try, and we took actually many more images of this building, so you would have many images to review and be able to use as part of your safety protocols. Here are some examples of being able to replicate flight plans and also being able to acquire data and analyze data. So on the left here, we have a flight plan that you can see the green transects here. This is the Oak Grove at IUP. And so we can fly this flight plan, this exact same flight plan, the exact same altitude with the exact same order of imagery and overlap of imagery again and again if we want to do that. And so it makes it quite easy to document that you're flying the same exact area and what changing conditions are. Over here on the right, our students flew a thermal sensor mission of the center part of campus. And what you can see is this was a cold day, and it was quite easy to see where heat was escaping from buildings. So, and some of the buildings are quite old. If you look over here on the left, this entire building is actually, is leaking a lot of heat. And that's because that building is old and it's on the National Historic Register and can't be modified. But one thing you can see right here where I've got the laser pointer, this was a location where we found that heat was leaking, and whenever we showed to engineering and construction, they had no explanation for that, and it turns out that the roof was compromised. So again, in this instance, that could be repaired, that could be addressed, and then we could fly it again to verify that heat was not escaping or that the surface had been adequately repaired. More examples of the ability to replicate flights and data collection and integrate it into your other platforms and systems. So on the left over here, this is a research project that we're undertaking to use drones and actually a multispectral sensor and be able to compare that to ground collected data. In this instance, we're trying to document the location and dispersion of an invasive plant called Japanese barberry. And so what we did was fly the drone scene using this special multispectral sensor. The multispectral sensor is recording light in different spectra, and including red edge, which is not visible to the human eye, and near infrared. and then we process that data, and then all these little dots right here are when we walk the forest and manually recorded with GPS units the location of the Japanese barberry. So this research project was about trying to see how effective the drone could be in identifying an invasive plant in northern hardwood forest. And then over here on the right, we have the ability of most commercial grade drones to model landscapes in 3 dimensions. So you can see here, this is the Oak Grove part of the IUP campus, and we're able to build quite accurate 3-dimensional models of the built environment. And these models are accurate such that we're able to measure on the walls of these buildings, measure on the roofs of these buildings, and be able to quantify that information, which could be very, very useful in many types of scenarios. Okay, now on to the cons or negatives of drone use. We have to be realistic. If we're going to be considering the use of drones in the safety workplace, what are the requirements, the responsibilities, the costs of doing so? So first on the list is operator certification and flight skills. So if you're going to have folks working and using drones in your safety environment, at least one and probably more than one of your safety staff will need to become FAA certified. The official title of this is FAA Certified Remote Pilot. And so in order to become certified, you need to pass what's called the FAA Aeronautical Knowledge Exam. And we'll be talking about that in a little bit. So you'll need to pass that exam. You'll need to pass a TSA background check. And then you'll need to be able to fly drones and perform the maneuvers that you'll need to perform, and or plan automated flight plans to perform the surveillance and collect the data that you want to collect. Second on the list are liability issues. This is something that everyone thinks about, and surely the management of your organization or company will be thinking about. And so you're going to need to deal with that. Usually people who are flying drones are going to want to have some kind of liability insurance so that they can fly confidently and not have to worry about any kind of issues that might happen if something did not go 100% as planned with a drone flight mission. And the other thing is you may want to insure the drones that you're using in your operation. That would not necessarily be liability, but obviously it would be a cost if something happened to the drones. Privacy issues are always something people think about. A lot of times you'll read about it, and sometimes when you speak to people, that's one of the first things they bring up. So they will have to be accounted for. Most of the time when you're collecting data in a professional environment, you're not in any way or have no intention to invade anyone's privacy, but you'll still need to have policies regarding this in your organization. Certainly, when using drones, weather, if you're going to be flying outside, and the flight environment are always a concern. So certainly, like for example, at IUP, we have a policy: we do not fly when there's any precipitation. And the reason for that is it increases the risk, and it's a riskier flight environment. So there could be circumstances when, another instance in our region would be high wind. So you'd have to deal with that. Now, if you're flying inside, you obviously do not have to deal with that. Airspace limitations. So some of your locations could be in what's called controlled airspace. Controlled airspace is airspace that's been defined by the FAA as having a limited access, mainly for commercial flights around airports. There could be other airspace limitations, but most of them have to do with airports and airspace. Regulatory compliance. So if you're going to have an operation within your safety department, you're going to need to comply with what's called Part 107. Part 107 are the regulations that the FAA wrote to govern the use of small uncrewed aircraft or drones in the United States. I'll be talking about the basics of the requirements of Part 107, but you'll need to become thoroughly familiar with that. And if you were becoming an FAA certified pilot, you would become familiar with those. And then there's the maintenance costs for the drones themselves. So they're like any other piece of equipment. They do have maintenance costs, and those will have to be accounted for as part of your operation. So this slide is just illustrating some of those requirements for drone use. So at the upper left here, this is my remote pilot certificate from the FAA. So whenever I passed the aeronautical knowledge exam, and whenever I receive my TSA background check, then they'll give you a temporary remote pilot certificate, but then you'll receive a card that looks just like this. So you can see I received mine on June 22nd, 2017. And you'll need that to, if you're going to be leading a drone operation or if you're going to be participating. Down here at the bottom left is just a segment of what's called an aeronautical chart. So these are the charts that we need to be able to read as drone pilots and understand controlled airspace. So this is a fairly complex controlled airspace system around Pittsburgh International Airport. I am in Indiana County as I speak here, and in Indiana County, IUP and surrounding areas are not in controlled airspace. So we're fortunate in that respect. If you are in controlled airspace, there are procedures to receive permission to fly to undertake your operations. And then finally, up here on the right side of the screen is an insurance quote from a company called Skywatch AI. That just happens to be the company that we at IUP have our drone insurance with. So myself and another faculty member have what's called hull insurance, which is we have liability coverage for ourselves, $2 million in annual liability insurance, and then some of our drones are covered with a 10% deductible. You can see at the bottom. So we have the drones that we want to be covered on this insurance policy. They'll ask for a valuation of those drones, and then they're listed on the policy, and then there's an annual charge for that insurance. But if you're going to have a drone operation as part of your safety program, you're likely going to look into some form of insurance, at least for the drones, and perhaps for liability for your pilots. A quick rundown of the major provisions of Part 107, which are the guidelines written by the FAA regarding drone use in the United States. And I'm just going to go down the list here. The uncrewed aircraft must be flown within visual line of sight, which means the person controlling the aircraft must have the drone within visual line of sight without any aid the whole time they're flying it. And that's obviously a limiting factor and a very important factor in following the regulations. The maximum altitude for flying small uncrewed aircraft in the United States set by the FAA is 400 feet above ground level. That's normally referred to as 400 feet AGL. The exception is if you're within 400 horizontal feet of a structure or a tower. If you are, then you may be able to fly up to 400 feet above the top of the structure or tower. You can do that as long as you're not impinging on any other controlled airspace. The maximum ground speed for flying a drone in the United States, according to the FAA, is 87 knots or 100 miles per hour. I've never come close to flying a drone that fast. And the reason that I haven't is I'm usually trying to collect data and get clear imagery. And normally we're wanting to fly at lower speeds and uniform speeds to do that. You must have minimum visibility of 3 statute miles, and that would be based on the weather and atmospheric conditions. You may undertake sustained operation over people, but if you do, you're going to need to have measures in place or mitigation measures to limit the kinetic impact of that drone if it were to hit somebody. My personal take on this is we really try to avoid flying directly over people. A lot of times that you can collect data about people or about crowds or about what people are doing without flying over them, and that's normally what I try to do. You may fly in controlled airspace like Class B, C, or D airspace, but you will have to get a waiver to do that from air traffic control. There are ways to do that if you need to. flying controlled airspace. Class G airspace is the airspace that the FAA says we're allowed to fly in that is not controlled, and that has been set aside for the use of drones. The rule regarding interaction with manned aircraft is at the present time under Part 107, if there's manned aircraft anywhere in the area, we need to cease and desist. Drones need to get out of the way of manned aircraft, and we would have to follow that. The eligibility requirements to become or remain a certified remote pilot we will cover, but it is part 107, and I did give you a little bit of information about that. You must register your drone or your small uncrewed aircraft with the FAA if it weighs between 0.55 and 55 pounds. So most of the drones that you would have would be required to be registered with the FAA. One last thing, and something that's important, is if you're flying inside, if you're flying a drone inside, Part 107 does not apply to you. Why? Because if you're flying inside of a building, you're not flying in the United States National Airspace System. So flying indoors does not require flying under Part 107. However, flying indoors, you're going to want to be very careful. You're not going to have the aid of GPS in terms of stability with flight, but Part 107 does not apply if you're flying inside. The requirements for becoming a certified remote pilot, an FAA certified remote pilot, are on this slide. So first, you must pass the FAA Aeronautical Knowledge Test at an FAA Knowledge Testing Center. So the FAA has hundreds of knowledge testing centers across the United States. Here in Western PA, we have a couple of these centers in Allegheny County. We have one in Butler County. We have one in Cambria County. We have one in Westmoreland County, and those are the places where you can take the exam. I'll be talking a little bit about what's on the exam in a minute. You must also, whenever you sign up for the knowledge exam, you also provide permission for a background check on yourself. And if you pass the aeronautical knowledge exam and the background check, then you will be able to receive your remote pilot certificate. With regard to the FAA Aeronautical Knowledge Exam, you can see here a little chart telling you the general knowledge requirements to take the exam. So regulations, in other words, the regulations under Part 107 and I had those on a previous slide. Airspace, so being able to recognize airspace and understand the requirements of the FAA related to that airspace. Understanding weather, aspects of weather and Earth atmosphere that would contribute to situational awareness for drone pilots. Loading and performance would have to do with payload on drones and the impact of payload and various maneuvers on drone performance. And then operations, being familiar with the operations of airports, being familiar with the operations of drones themselves would make up the questions that you would be asked to answer on the FAA Aeronautical Knowledge Exam. You can see there are 800 plus FAA approved testing centers in the United States. And if you do pass the initial exam, you will need to pass a recurrent exam and recurrent training, but there's no cost for that, and you can't fail it. So basically, you're just reviewing new material from the FAA and then verifying that you have mastered that material. Now, if you decide to take the plunge and implement the use of drones in your safety program, one of the things that you're absolutely going to need to do is implement a drone policy for your company or organization. So what you see on this slide is the drone policy we have here at IUP. And to develop that, I worked with the upper administration at IUP as well as the police department to put this policy together, and everyone on campus knows what it is and needs to comply with it. And obviously you want it to be easy to understand, and you want people to not have any problems understanding what's going to be required if they want to use drones in your organization. Here are some major aspects of our drone policy, just as an example. So here at IUP, only people who are FAA certified remote pilots are going to be permitted to undertake flights on university property. It doesn't mean everyone who's FAA certified will be. It means only people who are FAA certified. And of course, they must comply with Part 107. We do not allow any recreational personal use of drones on the IUP campus. And sometimes people are not that happy or excited about this, but that's what we decided to do as part of our policy, because we really were looking at the use of drones for professional and academic purposes. If you want to request to do drone flights over the IUP campus, you have to make that request at least 5 business days in advance. And then the IUP Police Department will review your request and notify you within 48 hours whether your request has been approved. And then, of course, UAS operators are responsible for all pre-flight safety checks. That's going to be part of what you learn as a remote pilot. And the last item here, just like anywhere, but we decided to say it explicitly in the policy, you cannot use drones to abrogate somebody's right to privacy, or to surveil them, or to record their activities. The other thing that you will need to do if you're going to implement the use of drones in your safety program is develop pre-flight planning and procedures that everyone in your organization will follow. So if you look on this slide, on the left side, the document on the left side of the screen is our pre-flight mission planning preparatory plan. So these are the procedures and the steps that our students and our folks in our certificate program go through to undertake the planning of a drone flight mission. And the idea here is to plan very thoroughly, to limit risk, and to identify all hazards and mitigate those hazards. On the right, you see our pre-flight inspection and field log. So this is day of, and basically what this is taking aspects of Part 107, putting them on our pre-flight checklist to make sure that everybody is complying with our policies and procedures. This slide is detailing our safety risk management program at IUP, and certainly it would be applicable to many other types of organizations. So you can see here at the top, our basic tenet is we're only going to conduct flights when the benefits derived from the mission outweigh the probability and severity of the risk associated with the mission. So we're always trying to limit risk, but there has to be quantifiable benefit to undertaking these flights. So step 1 is to identify hazards in our flight mission area and to assess those hazards. Step 2. Step 3 would be to analyze risk controls to the maximum degree possible and to implement risk mitigation. Step 4. And then step 5 would be to do a mission debrief, so to look at the missions we've undertaken, how they went, and how we could learn from them. The second large bullet is time critical risk analysis. So we're trying to plan as much as we can in advance of the flight mission, before the flight mission, become thoroughly familiar with what we're going to do, what the objectives of the flight mission are, the type of data we want to acquire, and so forth. But on the day of, things could change, and you need to do a thorough, thorough and honest evaluation. Has anything changed from my initial assessment, and do we need to employ a flight risk assessment tool to identify these short-term problems? Finally, I wanted to provide this information to you as I end up my part of the presentation, which is, one of the things I said to you earlier is one of the major aspects of Part 107 is that we have to fly drones within line of sight. We always need to be able to have our naked eye on that drone as it's flying. But there are things happening right now, sort of as we speak, where regulations are being evaluated and modified, and that effort is commonly called Part 108. And what a big part of what 108 is the ability to fly drones beyond line of sight for commercial operations, which would obviously increase the utility of drone use and enable us to do a lot more things. And so Congress has given FAA that mandate, and the FAA is testing, doing beta testing on beyond visual line of sight at a couple locations in the United States. And the reason I'm telling you that is if you implement the use of drones now in your organization, I think the value added and the leverage in the future will be actually significantly greater, because being able to use beyond visual line of sight. So that's coming down the pike. The next part of the presentation is going to be from Julia Wazen. She is a certified safety professional and also a student who participated in our uncrewed aircraft systems program at IUP. And Julia will be talking to you about the experiences that she's had as a safety professional in the use of drones.
We can use drones for risk assessment and risk reduction. In this section, I will cover a couple different examples of use that I can personally attest to. There are benefits to using drones in your workplace. We can remove individuals from some higher risk activities, such as inspections and assessment in hard to reach or dangerous areas. Remote assessments can be done from a distance, so long as you are still within the range of the controller and the drone's capabilities. The distance varies per model and the established visual line of sight, if applicable. We can also have improved surveillance in areas requiring more security. The entire time you are piloting a drone, you're able to get real-time updates. You should be able to see what the drone is seeing. Some of this data can be used for immediate interpretation, such as doing a visual inspection, or we may be able to collect images and elevation data and interpret it later for different uses. There are many applications for drones. This list is not comprehensive. Some of the applications I'll review here are general indoor flights, pre-construction surveys, real-time monitoring, inspections, and emergency planning and response. When it comes to surveys and planning, I know a lot of people like to just use Google Earth. They say they could pull a lot of data from there, and sure, you can, but if you ask me, a really big advantage from using drones is you can get real-time data. Google has to recapture their data every few years, and even then, it might not be as current as you need it to be. Using a drone and getting that data maybe a few days in advance is going to be much more accurate, and you have the freedom to capture more data as your project progresses. This is a model of a church in Pittsburgh, Pennsylvania that was looking to get some roof work done, including a possible replacement due to age. The estimator and I on this project needed to gauge where any potential leaks were, but we also were looking at the elevation of the bell tower. We needed to know how high and how long our scaffolding would need to be, which would allow us to figure out how many frames, decks, and rails were needed. This image is called an orthomosaic, a high-quality image stitched together from approximately 400 images that were shot while we flew the drone over the church. The whole time it was collecting data on differences in heights between the sections of the building. Luckily, the area around it was pretty flat, so we did not need to have much focus on the uneven terrain. So this did spit out elevation data, and though I don't have the key for the elevation differences on this image that we see, the red, the highest area, was about 115 feet from the ground. The mid parts in green and yellow were between 70 and 75 feet, depending on if you were at that point or the gutters. We can also see the darkest shade of red, showing that there was a parapet on the highest part, as well as a flue. When you look at the full 3D model, we could also see the difference in elevation of the gutters on the top, showing that one section of gutters was sagging in the middle and would need to be repaired or replaced. Using this information, we could bid the job using more accurate numbers of scaffolding components and how much roofing material we would need. Another benefit, and probably a big one, is real-time monitoring of your site. This can be things like crane activity, vehicle or personnel movement, utility inspections, at-height inspections, and potentially accident investigation. So here we can look at these two orthomosaic images. They are job sites at various levels of completion. This is great for getting a look at project progression, especially when looking at images of the same site taken at different times, but we can also use these images for safety planning purposes. The bird's eye view can allow us to see things like different roadways in and out of the site, or maybe where we would need to establish laydown on our site. You can mark safety zones like restricted areas, staging zones for material, and emergency exits directly on the orthomosaic image. This can be communicated to your site and ensures that everyone knows where they should and shouldn't be. With periodic site images, you can monitor worker movement and activities on site. This can help us identify areas where workers may be at risk, especially if certain zones become too crowded or workers are not following the designated paths. The imagery can be cross-referenced with safety protocols to ensure that workers are adhering to proper routes, using the right equipment, and staying in their designated zones. By comparing new images with previous ones, you can identify new hazards or changes on the site. For example, newly exposed trenches, scaffolding issues, or machinery that could be in unsafe locations. Images like these can help identify environmental hazards such as water pooling, loose soil, or erosions that could pose a risk to workers or machinery. Another example here, this is a masonry job using a crank-up scaffold tower. The crew was constructing an elevator shaft and was about 50 feet up at the time on the crank-up scaffold. Instead of climbing the tower, you can send up a drone. For this inspection, we were just looking at PPE compliance. So using the drone, we identified 8 workers on the scaffold at the time. We can see that everyone had on their hard hats, glasses, and high visibility shirt that were required for the job site. We can also see that the scaffold was fully planked and had guardrails on all sides, top and mid-rail. A big benefit we have with drones is being able to access unstable or unknown structures. There may be times when we are unsure if a building or an area is safe for us to access. Some examples may be after a fire, an earthquake, or other natural disaster. If we want to inspect an older structure, maybe one that has been poorly maintained or not maintained at all, we can also do that. We can also use drones to survey crawl spaces or tough to access areas. The biggest benefit to this is that no one has to make entry into these spaces. We don't have to put people in harm's way when we are assessing areas that we are not sure of. The image shown here is a hard-to-reach area. This was under a concrete slab that was functioning like a bridge. It looked unstable from above, so I sent a drone underneath, only to find out that it was being held up by 2 wooden horses. This one is a bit hard to see, but this is a residential roof that had significant sag. The house had been flipped by investors, which we know probably does not always yield the best results. When touring a house looking to buy, or when someone is potentially going inside to renovate, people do not normally look in the attic at the state of the supports or climb on the roof to look for soft spots. Normally you don't find out that information until it is too late, such as when actually climbing on the roof for repairs. The angle of the house and the roof from the street level did not allow you to see the area with the sagging, but taking a drone up to the roof allowed me to see that there was a spot where the supports underneath were rotted away. If someone had gone up to the roof and stood in this area, they may have fallen. When it comes to indoor applications, the FAA does not regulate indoor activity like they do outdoors, so a Part 107 license is not required. However, please review your local laws and company policy before proceeding with an indoor flight. Flying indoors may allow you to more easily access hard-to-reach areas, such as if inspecting above or inside of machinery. This can eliminate some of the need to work at heights or enter a confined space. Industries that may benefit the most from this include manufacturing and warehousing. However, we must note that flying indoors does have some cons. It takes more skill to fly indoors than outdoors. Certain controls may automatically disable when flying indoors. You may not have access to GPS, and this can impact the drone's ability to self-stabilize. It may also result in the loss of obstacle avoidance, and you will have to manually fly the device around obstacles. Magnetic interference can come from any electrical device in the building. This can interact with the signal between your controller and drone. It is best to fly smaller drones indoors, and I recommend you add propeller guards to them if they came with them. It is recommended that only experienced drone pilots fly indoors. Avoid flying near walls, ceilings, or close to the floor, and fly at a minimum speed and closely monitor altitude. Drones can be used before, during, and after an emergency. Before an emergency occurs, we can use drones to help develop our emergency action plan. Some things you may choose to do is use drones to get an aerial view of your facility or site. Creating an accurate map with up-to-date egress points can allow employees to exit safely should there be an emergency. When disaster strikes, there may be changes to these egress routes in the moment. Sending a drone to the area may help you identify routes that could have been compromised, for example with falling debris or a fire blocking the path. You can very quickly identify new and safer routes for egress. You can also encourage employees to follow the drone to a safer route. In the aftermath of a disaster, you may need to visually inspect structures or utilities. For example, the city of San Francisco, California, deploys a fleet of drones after earthquakes to inspect piers and seawalls. This replaces their previous boat fleet, and the drones can be deployed within hours, whereas a boat could potentially need days to deploy. In previous jobs, I have deployed drones to detect potentially compromised gas lines after seismic activity or during fires to locate individuals and compromised egress routes. After an incident or natural disaster, individuals may go missing or may get lost when trying to reach safety. Using drones for search and rescue is something first responders have been using lately, and I personally think this is a great use of technology. A drone can cover much more area than a team of people and their dogs could in the same amount of time. Using thermal imaging cameras can help find missing individuals or at least see what route they had been taking. Once a person has been spotted, the drone reports to the controller in real time. Approximate coordinates are also transmitted, pinpointing the area for first responders to go to look for rescue. Drones also make a distinct sound, and they are required by the FAA to have lights. These can be used to alert someone that help is coming and or to guide them to a safer area if possible. Something we may not think about on our sites, especially those of us that work in remote areas or certain construction sites or utility sites, we may encounter protected species such as birds or other wildlife. Birds may be inclined to nest in substations, power plant cooling towers, or high points of manufacturing facilities. Most states do not allow you to touch protected wildlife, and there may be significant legal ramifications if you do mess with the wildlife. Wildlife can damage the integrity of systems and structures. This may delay projects or necessitate repairs and rework. Trying to chase off animals may also result in them attacking employees, and I can personally say that I've witnessed that. Instead of trying to chase off animals using individuals or potentially incurring environmental infractions, drones have been used to remotely monitor the progression of nests, especially if there are babies involved. You can use this gathered information to determine if a nest is abandoned and can be properly removed, or to gauge when the nest will be abandoned. Now, we need to be real because we are safety professionals and part of our job is to prepare for the worst case scenario. Although drones may be a safer option for some applications, it is not without risk. You should be prepared to have an incident involving a drone. For example, weather can change, sometimes unexpectedly and rapidly. Even though most drones will self-stabilize, this is not foolproof. Strong winds may knock a drone off course. The blades of a drone can spin up to 20,000 rotations per minute. These blades can and will lacerate you if you attempt to touch them when they are in motion. Geofencing is something you may not think of, but certain institutions may put up a geofence around their facility. The drone may pick up on this and not allow you to fly too close to that area. Drones also carry a negative connotation to some individuals, especially if someone is unaware that you are flying nearby. They may feel like their personal safety or their privacy is being compromised. It is not legal per the FAA to shoot down a drone, but I can personally attest that not everyone is aware of this, and people may behave a bit erratically when they feel their safety or privacy is being compromised. To combat the worst case scenarios, there are some things we can do to complete our mission and prevent incident. Watch the weather and look at notices to airmen. Simply knowing when bad weather may strike or if there is unusual activity in the skies can help you plan your flight mission properly and prevent weather-related incidents. To prevent any injury from the drone itself, make sure that you, your team, and any bystanders steer clear of the drone from takeoff, while in flight, and while landing. The rotors begin to spin a few seconds before the drone becomes airborne, and it takes a few seconds after landing to come to a complete stop. Do not attempt to handle the drone after takeoff, and do not attempt to handle the drone while in flight. Wait until it is on the ground and has completely stopped. Do not fly directly over people if you can avoid doing so, and make sure no one stands in the flight path. Make sure that your batteries are fully charged to avoid the mission coming to an abrupt stop. To counteract potential geofencing, make sure you are aware of your proximity to sites such as prisons, airports, government buildings, and others that may try to block a drone from entering the area or could potentially interrupt signal between the controller and drone. Part of being a Part 107 pilot is knowing where it is and is not legal to fly over with a drone. And make sure that you have an established flight path before starting the mission and identify all participants in the mission. Those who are in the area but may not be involved in the flight will benefit from the notification of the flight.